So it won't be too crowded up here, and sure technology works. So I'm Colin Bannister. I'm the technical director for Northern Europe for VMware. It sounds a very grand title. Trust me, it's not quite so grand. And really, I want to kind of take a few minutes to kind of set the stage. And looking around the room, you might not quite be feeling it this way this morning, but I think it is the most exciting time to be in the IT industry. And as you can tell, it's been a little while since I went to university, and things have dramatically changed since. And I kind of say that I'm quite lucky because I get to travel around a bit, and I get to travel and meet many customers, and I truly believe that it's the most exciting time because, for one reason, technology is disrupting every single industry vertical, and I kind of think that the higher education is leading the way around disruption, using technology to disrupt your business model. So I just want to spend a few minutes talking about, why should we care about software-defined? Why do we need to consider a different approach to how we deliver IT services? And I feel a little bit nervous up here talking to you guys about something you know really well, because I'm not an expert in higher education. But I thought I'd just kind of share some of the observations that we see from around the organisations that we deal with. And as I say, technology there's massive disruption because of the way we've turned students into potential clients and customers. The whole way we do the funding mechanism for students, the amount of choice they have, the amount of different delivery mechanisms for education, where students do their learning. And if my daughter is anything to go by, she does it from her bedroom. So that's typically where she seems to do most of her study. So every space now is a learning space. And if you kind of look at both your academics and staff and the students, they're bringing high-tech technology into your infrastructure world, and you need to manage that. So there's huge disruption. And some of the things that are kind of changing it, there's a lot of competition. Typically we think of competition in the private sector space, but in public sector and higher education there are many more learning institutions that you guys have to compete with, which means there is pressure on your budgets. Very topical around the whole fee structure for higher education, so there's lots in the press around the fees, but again, the students, your potential students, are much better informed around their choices and their options when it comes to where they might choose to do their higher education. Online delivery models are changing the way you do your teaching and deliver teaching, and the big thing for that is it reduces the barriers to entry for new competitors, again putting pressure on budgets and IT. Lots more collaboration around the research piece, which has implications around IP ownership and IP security. And again, the shift away from big teaching modules, big dissertations, to much shorter term learning experiences affects the way that you will deliver your services. So the business models are kind of changing, and the demographics and who you're targeting are different. So the expectations of not just the students, but your academic researchers is different. The expectations on the technology and how you deliver technology is changing. We all want a much more sleek self-service access to the applications that we need. The demographic is changing. So it used to be the 18-year-olds were the real target, but there's many more mature students entering higher education. So that changes the way and changes the mechanism and the attendance to on-site campuses. And then finally, unfortunately, there are people out there who continue to stretch the security boundaries to attack our IP, and that's an increasing threat out there. And if you kind of look at a day in the life, what are the stresses and challenges that you guys face on a daily basis? You've got all how do you enable all of the devices that are coming into your network, whether they're devices that you provide, whether they're devices, bring your own devices from students and academics. There's the whole onboarding of devices. How do you manage that? How do you do the onboarding of individuals when you've got such a huge churn every year of tens of thousands of students potentially? How do you do identity management of those individuals? How do you provision applications? whether they're productivity applications or specialized applications. All these types of things are significant challenges, and you could draw the same parallels with the academics and the staff. So the day in the life, the expectations of the people are completely different today to historically. And so, from an IT perspective, what does that mean? How does that then manifest itself in your organisation? So, the whole shift to cloud changes the economics of how you deliver infrastructure. The growing complexity. I used to run data centres for a big high street bank many years ago, and the biggest challenge, and it continues to be the biggest challenge, I believe, in how you support and deliver IT is complexity. There is no such thing as a greenfield site anymore. So how do you manage all of this shift and change whilst you've got legacy systems, legacy applications, so complexity is probably one of the biggest challenges. And then the whole ability to provision applications to the users on the device when they need it, in the format they need it, continues to be some of the huge pain points. So how are we going about addressing it? And we have a very simple simple to articulate, well, not that simple clearly, strategy for how we're approaching it. And it's kind of interesting for an infrastructure-focused company. I firmly believe it's got nothing to do with the infrastructure. It's all about the application or the service that you're delivering. It's all about how you deliver and consume the services that you deliver. That's the kind of key piece to. And you've got traditional services, you've got new cloud-based services, you've got SaaS applications out there. So you've got a whole raft of different types of applications and services that you're trying to deliver. And the key to that is how do you deliver that to any device? So key to kind of our vision is through our Workspace ONE technology, whether it's traditional desktop or mobile devices, it's delivering all of those applications and services in the most appropriate format to any device at a moment in time that it's needed. So key to our strategy is any application to any device, built on a infrastructure that increasingly, and we kind of launched the kind of new positioning at VMworld 2 or 3 weeks ago, is the cross-cloud architecture. So it's kind of as leaders in the private cloud and hybrid cloud, we're extending our capability to be able to leverage that software-defined data center into the public cloud as well. So VMware Cloud Foundation is a packaged SDDC in a box, if you like. So removing a lot of the overhead of how to implement both virtualized compute, networking and storage with a management layer to take away a lot of the administrative installation, to speed up the deployment of a software-defined cloud, increasingly delivered as a service. So if anybody saw our announcement 2 or 3 weeks ago with the first announcement with IBM and their software technology to be able to deliver the VMware Cloud Foundation as a service. So you can now procure a software-defined data center as a service from IBM. We launched first with. You'll see a lot more announcements in the upcoming weeks, which I'm glad to talk about. But stay tuned to some significant announcements from us around some of the big public cloud providers as well. So being able to give freedom and control, to be able to deliver, manage and govern applications in any cloud environment is our strategy, delivered to any device. So that's kind of our vision. The guys are kind of, I do the wonderful marketing stuff. The guys are going to talk a little bit more about how and what. But visions are great, but where do you start? How do you know where to go about starting on your journey? Because as I said, you're not starting with a greenfield site or a clean sheet of paper. So we've got many different starting points depending on where you are in your maturity of delivering cloud-based services. So I've just kind of listed a few up here of areas that we see customers using to start, whether you're challenged with your OpEx, your CapEx, whether you're challenged on your security portfolio, your security posture, whether you're focused on creating this optimal experience for your students and your academics and your staff around this single device, single portal access to any service, irrespective of where it sits in the infrastructure. So we've got a number of different starting points depending on where you are. So because clearly this is a journey to a software-defined data center. It's not a straightforward step. So I just kind of wanted to set the scene as to kind of why is it different. We are hugely challenged. It's hugely competitive. You guys are you've got a really significant challenge is how you transform your IT infrastructure to be more consumer-driven, because the students and academics are being much more choosy about where they choose to do their higher education. So that was kind of it from me. I'll hand over to Adam from Softcat, who'll kind of talk a little bit more about the how do you go about doing this stuff. So, Adam.
Thank you. Thank you very much. We'll let the guys sit down. Good morning, everyone. There's a lot of you here. Okay, so I'm going to start, as all good things you should, with a rant. Nothing really should be started without a good rant. And I'm going to rant about the software-defined something. It's my biggest bugbear. I hate it. I hate it. I hate it. I hate it. What does it mean? It's literally rubbish. It's marketing speak. The software-defined something is the biggest marketing fad I've ever heard. When was the last time something wasn't defined in software? When was the last time you bought a box and it just did something? Seriously, like, everything is defined by software. You put code into it, you give it instructions, you define what it should do. So the software-defined something is not what we should be thinking about. The software-defined something is a way of distracting you from the real benefits that are actually gained out of this. You know, when you actually start to look at, and I spoke to customers, and usually as I do, I rant at them, mainly because they take meetings from me, I have no idea why. And I sort of sit there and I say, like, I'm thinking this, what do you think? And they would say to me, and I'd say, what is the software-defined something? What do you want? And they'd say, actually, I want something that's agile. You know, agility-defined, software-defined. You know, the idea that something doesn't have a fixed format, that I can change it, that I can mold it, that it will adapt to what I need as a business. That it's elastic, that it can grow, that it can shrink. You know, it's automated. I don't want to always have to integrate and touch it and configure it. I want it to configure itself. I want it to take inputs in from other systems. I want it to be self-service. Ideally, I want to sit there making tea all day and have everyone else do all the hard work. I want it to be measurable. You know, one of the really big things I think that comes out of software-defined or any of this sort of technology is the idea of measurement, the idea of empirically judging the value of something and making your decisions based on numbers. I want it to be consumable. You know, I want to be able to come and just take it. I want it to be like water, like a utility. And I want it to be cloud-ready, which is just someone else's data center. Eventually, I don't want to own it. And kind of when you look at all those words, and you actually looked at what you were trying to say when you were saying, I want to software-define something, you don't want to software-define something. You want IT as a service. You want your own IT to operate as a cloud, as a service provider. You know, you want infrastructure as a service. And all these technologies that we're standing and talking to you about today are just dripping down from the service provider industry. All that's happened is the big boys out there who've had to sit there and work out how do I, as cheaply as possible, as efficiently as possible, deliver infrastructure in a way that actually is cost effective. And all we're doing is we're taking those technologies and dropping them down. So I guess back to a little bit to about actually UCLan and the work we did with them. About sort of the story begins 18 months ago when unfortunately UCLan were left with the last decision in the book to take a meeting from me. And they said to me, Adam, you know, what we really need to do is we need to have a look at our security. We've got some aging firewalls. And we sort of sat down, and I think the really easy thing to do as a supplier would have been, oh, we sell some firewalls, here you go. But what we actually did is we looked at how you could do it and what's the better way of achieving that. And we started on this journey together, which we'll sort of demonstrate here. So, as with all good things, abstract diagrams. This is sort of my way of putting an infrastructure. Generally, you have some sort of security boundary, and you have some sort of service in the middle, and typically you have the good guys inside the security boundary, and you have your threat actors outside, and it's all very simple. And the problem is that never works, because typically you have users that either go outside the security boundary and become compromised, or you have users that are already compromised within the security boundary. And all of a sudden, all that investment you've made in security disappears. And actually, you're fully exposed to those compromised users. So what typically happens, and you know, I'm pretty sure this would be reflective in what you've all got today, is you put some internal firewalls up. Departmental firewalls, distributed firewalling. And the first thing you do when you buy those firewalls is you poke loads of holes through them so people can access their services. You know, they don't really offer you any real security boundary. So the first thing we did at UCLan, which was slightly different, or maybe allowed us to move towards this sort of new world, or this more abstract world, was to deploy application delivery controllers. So what we did is we migrated all services behind those controllers. So I guess most people will be fairly familiar with how these things work, but at a high level, you drop every service behind it and you present it through the front of the application delivery controller, creating an abstraction layer that people will connect to the front end through. Now, this gives you a few benefits, actually, and as we kind of go into, I guess, into the future and we start looking at how we can start to automate more, it becomes more and more important that if we can see the users, rather than making direct communications with the servers, they access a virtual IP or a virtual presentation of that server. Now, that can always remain in the same place. And what that allows us to do is to play around with the stuff inside the data center without it affecting where the users go to access their applications. You know, it's for me, one of the biggest first steps anyone can sort of take towards an automated data center is putting that abstraction layer in at the network. You know, if you ever try and do anything particularly clever, for anyone, I guess most people here with an infrastructure background, try pointing people to different IP addresses. Try flipping DNS around. It never works. There's loads of caching. You know, it always falls over. Having a single presentation layer is massively important. What this also does is this obfuscates a lot of the internal infrastructure. Because of the nature of the application delivery controllers, they will only present services that must be accessed by users. So now you think about all the other parts of your squidgy infrastructure, the databases, the middleware, all the stuff that you don't want accessed by users is now hidden. And a user can't get to that. It's non-routable, it's non-accessible. So what you've done is you've made a massive risk reduction by putting this layer in. But the clever amongst you will say, well, Adam, we're all intelligent infrastructure people here. What happens if I compromise one of those servers? You know, standard technique is going to be moving across the infrastructure, lateral movement. Well, I'm back to that full exposure again. All of a sudden, all this money that you've spent, all this investment that you've made has not made you any more secure. So this is where we can talk about going down to a microservices architecture or a microsegmentation architecture. And this, for me, is, you know, one of the massive things that is only now possible because of the introduction of hypervisor-based firewalling. You know, previously it was almost an impossibility to manage and administer a hardware platform at that scale without actually either making a mistake yourself or leaving it so open that it was pointless in the first place. And this is essentially the architecture we've gone down to. The interesting thing about going to a microservice is by building that bubble, you have to truly understand the inputs and outputs of that system. You must understand all the things that make up that system and make it work. You know, I mean, I'm pretty sure that most of you sitting here now probably don't have a handle on 100% of what actually drives each application. Maybe you've all got very mature enterprise architecture. But the reality is, I see it in most customers, is if you said, point to that system over there, what does it rely on? I don't really know. I couldn't really tell you. It just works. And the big problem that happens with this is, other than the security nature of that, is, well, if you don't understand that input and outputs, how do you move it to the cloud? I'm sure we're all sitting here being told that everything must go to the cloud. How do you move something to the cloud unless you understand what it exists in isolation? So we create this idea of a microsegment. And this is kind of where we've got to with UCloud. You know, as with these things, you kind of have to draw the line between reality and the possibility of the future, really. So what we've done is we've set this architecture up for the guys at UCloud now. So they have the presentation layer. They've just deployed VMware NSX. They've got some new firewalling in place. And what we're doing is we're migrating services into that environment. And as part of that migration into that environment, we perform the segmentation. We perform the isolation of the service. And we start to build a service catalog to understand what are the service requirements of that particular service in isolation. And that allows us to make decisions down the road. So, where do we go next? To the cloud. We've seen no Dilbert here. Maybe I've missed it. So I thought I'd bring some Dilbert along with me. Hopefully everyone can read it. The cloud still feels like a scary thing, which I kind of don't really get. I mean, we've been doing cloud forever. Cloud's just someone else's data center. But I do very much agree with some of the comments that were made yesterday around there is no guarantee in cloud. You know, you do not get guaranteed performance. And that's the nature of the beast. That's how it works as a commercial model. But if we look at some of those challenges about the cloud, when we think about those microsegments we had, well, because we actually isolated and understood them, and we had that single entry point into the infrastructure, we could start to move some of those segments somewhere else. That's someone else's data center. I did this presentation for the gents at Edinburgh who very set me straight and said, but Adam, data has mass. You can't just move stuff. You can't just be an architect to put it on a diagram and draw a dotted line. Well, I can, we know. But I probably shouldn't. You know, the real thing about moving a mobility to the cloud is actually, you know, you can't just chuck stuff up there. It doesn't work like that. It has mass. There is weight. There is electrons sitting on a drive somewhere. You can't just throw a 20 terabyte database up into Azure because you fancy it. Actually, you've got to plan it. And you've got to work out what's going to work best up there. You know, is it just a compute layer? Are you using it for storage? And this is, again, where that delivery becomes very important, because I actually don't see cloud migration happening. I see total locations of whole services up in the cloud, and then using the steering system at the top to push users to the best place to get their application. When I start to bring that back to how that actually affects you guys, you know, how many organizations here have a remote campus outside the UK? A fair number of you. So how many of you are trying to deliver the best education experience somewhere else? That's where these become really important, because actually you want to be delivering from local data centers. You want to be doing geolocation. You want to be delivering out of CDNs that are close to them. So actually they get the best performance. And these are the sort of technologies that allows you to achieve that. So now we have this idea of an infrastructure. You know, it's zero trust. We've created a strong security boundary. We've assumed all clients are compromised. We've got a single entry point in. And we've isolated services. Where could we go next? You know, and this is where we go to the world of tomorrow today. So, as Dilbert rightly puts it, you know, IoT and analytics and DevOps, and it's going to be cool, and we're all going to work at Google. Actually, the reality is massively far off of that. I don't know if I'm the monkey and you're the monkeys watching the monkey, but essentially there is merit in this. So we've gone back to our architecture. What we can start to do is, because we have this single entry point, we have this application delivery controller here up the top, actually that sees the telemetry, it sees the metrics, it sees the volume, it sees the health of the application, it sees the user accessing it. It has all that rich data. Well, wouldn't it be lovely if that could start to reach out to places? And this is where you start talking about an automation engine. Actually delivering via API or via something calling into it saying, hey, how's Blackboard doing? Yeah, it's pretty hammered. Okay, now I can do something. I can write business logic. I can write a process for it to start to enact, to actually change something. And because I have service bubbles, you have the idea of the ability to duplicate service bubbles. So if I can take that whole bubble and that's Blackboard, well, why can't I double it? And if I can double it, why can't I return the IP addresses to the load balancer? And all of a sudden now, I've scaled on-premise. I've given that cloud effect. And that's a really nice use case. You get a lot of other things you can start to look at as well. I'll sort of come on to it later, so I don't want to steal the thunder, but if anyone hasn't read the Google Site Recovery Engineering book, it's a very dry but good read. And that really talks about what's achievable here. So now you have this idea of an infrastructure, zero trust, it's strong security boundaries, you've isolated services, and you can start to stretch it and grow it. What else can you do? Well, I want to start to input into that machine, into that system. So that's the idea of bringing self-service in, and I kind of don't see self-service being an end-user thing, if I'm perfectly honest. One of the biggest challenges I see, and it's actually bringing back to a comment that was made yesterday, you know, we're all so scared of vendor lock-in. Like it's the worst thing since sliced bread. Do you know the opposite of vendor lock-in? It's called people lock-in. Because actually, if you don't pay the money for vendors to do things, you have to build something yourself. And that's great for the ones of you who can attract the 1%ers, you know, the best resource, and you can keep them at your university forever. But these sort of people are highly valued and highly skilled. And actually, I'm sure we've all got systems that are made out of black magic by some wizard who used to work here 20 years ago. And we've got no bloody support contracts. It's non-standard. You can't go on a bloody training course for it. So don't be afraid of vendor lock-in. You know, make good decisions, but vendor lock-in allows you to have support. So we have this idea of a self-service catalog, and what that also does is that allows you to essentially take tasks that would typically be only performed by your top-level guys and allow them to be performed by anyone, because you know they're done to their standard. So essentially exposing functionality that otherwise wouldn't be exposed to that level of person. So then we get on to the magic that is DevOps. Arthur, our DevOps wizard of the group. So the idea of infrastructure as code, you know, defining your infrastructure in a package that essentially can be run hundreds and thousands of times. For me, it's not that exciting. You know, I'm not sure how often everyone is deploying infrastructure. I don't think it's at the scale of the people who are really doing this. I'll tell you the bit that is interesting, actually. Once you get used to defining your infrastructure in code, you start to get used to actually unit testing it in code. Thinking like a programmer, regressive programming. So saying, I want to define this Windows server. It's an IIS box. And it has this security profile, it has this networking requirements, it gets this load balancing profile. Okay, click. We deployed it. All right, that was easy. How do I check that it worked? So actually being able to start to script in tests. I want to talk to my vulnerability scanner and say, hey, Nessus, scan that for me and let me know it's all right. Oh, okay. Hey, someone make an HTTP request to that box and make sure it returns an expected string. Start to actually test that the infrastructure is actually doing it. So then you can go to that next step, but that's a hell of a lot easier to define in code. And then you can go even further than that to actually say, well, actually, if we can start to do that, well, what we can start to do is we can start to say, if it isn't fine, here's what we do. Here is some business logic to fix it. And you can manage this stuff like you would any sort of code base. It's iterative. It develops, it changes, it reacts to whatever you're doing. And it's something that you'll always have. So now we've got this idea. We have of this infrastructure, zero trust, it's a strong security boundary, it's automated, we can input into it. What else could we start to do? This is the big one, cost analyze. How many of you really know how much it costs to run each service in isolation? Probably none of you. And doesn't that really matter? How do you fight a cloud conversation if you're fighting it? Or how would you as a business person look back to your business? At the end of the day, if we're all right and what we've been saying for the last couple of days is true, we're not going to survive forever as only IT people. Our job is to be the interface between the business and what we understand. So our value comes from actually being able to go back to the business and saying, I've analyzed this service and the way we're running it is either efficient or it isn't efficient. Without those tools, how are we going to have a conversation in their language? You know, our conversation just goes, well, I don't want it there. Or, I think I can do it better. These aren't empirical measures. And really, the biggest empirical measure is cost. The other interesting thing that comes with cost analysis is typically the way you analyze cost is we look at cost of the service. You know, and if we get to that level, that's kind of quite interesting. What I like to think about, and it's kind of more of a web way of looking at things, is cost per transaction. How many of you hate paying your Microsoft licensing? Okay, all of you, good. But actually, as a cost per transaction, that Microsoft license is probably the cheapest thing you own, unless the people who use Macs. But like it's a very cheap investment for the amount of stuff you get out of it. And I'm not here to tell you Microsoft. But actually, I bet you've got a bunch of line of business applications that are sitting out there that are finance systems, that are back office systems. They get used 4 times a year to run payroll. And they're costing you 200 grand to run an Oracle system. Sorry, Oracle, if they're still here. Or on other systems that have big support costs. And actually, we have no cost per transaction. And I think that's really important. And finally, it's getting to the idea of service level monitoring. We all do sort of SLA monitoring for uptime, downtime, or hopefully we do. For me, I want to start to look at, in this new world, how do you monitor user engagement? How do you monitor effectiveness of applications? If I upgrade Blackboard, I want to know that people are spending 5 minutes more with Blackboard every day. Because if they're not, why aren't they? Because it's not any better then. I've not improved anything. You know, actually, if all of a sudden I push a new application and it declines the amount of time a user spends with that application, I want to know why. Because otherwise, maybe they're not using it. You know, that sort of user engagement metrics and time metrics is particularly important as we start to migrate from just our traditional view of our job is to set up infrastructure to our job is to enable users to access what they need via technology. And this is sort of the journey that we've been going on with UCLAN, really. A lot of this is set in the future. You know, these guys are going to pull me straight and pull me back down to earth, really. And for me, the whole project that we've been on over the last 18 months and probably going forward into the next year is about providing the guys the tools. When we started this project, there was no chance that we could do any of this. You know, Frank will probably shake his head and say, no, that's not true. But, you know, there was no way that we had this ability to even take a tiny step forward to make things any different. Actually, by putting this baseline architecture in and putting these baseline tools in, whether they're VMware or they're whatever, I kind of don't care. What I think is really important is getting the pieces right. Because if you get the pieces right in the right order, you'll be able to make decisions in the future. And I just want to finish, before we go into the Q&A, by saying, look, a real piece of honesty, we don't have all the answers. I don't have all the answers as a supplier. Like, I don't know how to do all of this. And I don't think all of this even exists yet. But what I know is that this is the right direction of travel. Like, actually, we can't do everything we want to do. Like, there isn't a magic button that will just automate everything. We'll automate all the things, and suddenly we will just be sitting there drinking pina coladas and with our feet up. But actually, I know that if we don't move into this direction, we will succumb to it going somewhere else. Because people are already ahead of us. The service providers are ahead of us. They've been doing this for longer than us. And ultimately, they're the competition that potentially we're staring at for those who want to keep their infrastructure on-premise. Obviously, there's some of us who just want to get rid of it, and that's fine as well. But we've got to work out that if this is the direction of travel, then these are the steps we need to start going through, and this is the journey we need to be on together. So I'm going to open up some Q&A now if anyone has any questions. No questions? Was it that bad? Oh, I think we've got one over here. Oh, I've got another slide, actually.
I sort of asked this question yesterday, but it got kind of garbled. It was the last question at the panel, which was, I'm increasingly concerned about the very high level of abstraction that we're starting to introduce to the infrastructure. And the big question I get asked every single week is, how can you make it run faster? It's running slowly. If you have all of these connections that you have very little control over, and not always very clear where the problem lies in a very, deep system with application tier, database tier, infrastructure tier, how do you find those problems? I'm really worried about how, as a support person, I will fix it's running slow when I can't figure out where the problem is.
Yeah. I think that's quite an interesting thought, actually. One of the things about automation and orchestration, or any sort of abstraction, is abstraction makes it seem easier. It actually makes everything more complex. And that's kind of the nature of the beast to some extent. And that's a really challenging thing to actually overcome. Typically, the way I kind of believe these things will be fixed, if I'm perfectly honest, is by more automation. You'll fix automation with more automation. And that's a little bit where the Google book come in. And if you're interested in that sort of thing, Google SRE is a really good read. Because Google are, as you'd expect, 10 years probably ahead of us in terms of doing these things. And they're massively automated. As you imagine, when you're putting 10,000 servers out per week, there is no way you're going to do that manually. You have to automate it. So to answer your question, the way you actually start to support and maintain these systems is you have to constantly be checking they're okay. More regularly than a human can. That's where the API-driven or the automation-driven thing comes out, and it's that thing pokes Blackboard or pokes that system and says, hey, that little piece of the system, are you okay? And you start to not look at systems as complete things. They start to become very abstract or very individual units of a system. And we had that a couple of times mentioned previously about Lambda and this sort of stateless computing or functional, or sending functions straight to computers rather than having anything like that. And that's very much the sort of next evolution of that, is that total isolation of each function of the system. I think at the moment when we typically take a support case, the support case comes in and says it's slow. Well, it's slow means nothing. Whereas what the computer is going to give us, or the measurement is going to give us, is it's slow between this tiny process and that tiny process. And that's where the problem is. I don't think we'll be looking for the problems anymore. I think we'll be receiving the metrics. We'll be making decisions based on that. And hopefully there'll be some of it that we won't be making decisions on. The other part of that as well is, do we fix things anymore? Is there value in fixing? Or do you just roll back? There's very much the thought process that if you try and move away from state and to more modern application types, if it breaks, you just delete it. You just start it again. Let's start it from a known good state. If it's not working great now, let's go away, start a new one. Like, do we fix things anymore, or do we just recreate them? Does that sort of answer your question? Cool. No worries.
Can I just add to that?
Yeah?
When we first started off with the security project, we thought we understood our network, and it became quite evident that we didn't. It was a big old network, lots of resilience in there, and we didn't fully understand what was happening. And we brought one of the consultants in to put a black box on, just to look at what traffic's on there, and it scared the hell out of us. the amount of traffic that was on there, the amount of vulnerabilities we found, and during the 2 weeks that we had that box on there, I had 2.5 staff working nearly every day looking at those errors and problems that were coming up. I don't have that resource, and I'm not going to get that resource again, so we need to build in a great deal of automation on that. But I take your point. I'm scared of the fact that we need to get that right, the fact that we can make it too automated, and then when things do go wrong, we don't have the skill sets to actually address that. And that's a slow journey we're going to have to do. I mean, we started that already with putting in the appropriate amounts of training and identifying the skill sets that we require for that, but it is going to be a long and slow process. But the automation, I think we're going to have to tread quite carefully on that to make sure we don't lose control of our network.
Any further questions? Oh, one in the middle.
I just wondered, the guys from UCLan, how far you think you've got along the journey that's just been described, and what lessons you've already learned that the rest of us might find valuable.
Remember, I gave you that 50 quid, so say nice things.
Well, we've got all the way. We're there. It's all done. That would be a lovely thing to be able to say, but it's not true. We've got the kind of the crusty edges in place. We've got the load balancers in place. We're beginning on the sort of microsegmentation. That's the bit which I think needs a lot of care and attention, because it would be very easy to just say, right, let's chop everything up, let's isolate everything. But like Adam was saying earlier, you need to know what needs to talk to what, and you've got to do a lot of analysis and a lot of investigation before you even start to tie everything down, because you know, we're a university, we're there to support the students, and if we suddenly start breaking everything in the name of security, then you know, they're not going to see it that way. They're going to see us as being a bunch of idiots, which we don't want to appear.
The lessons that we did learn early on, the very early stage, I mean, we had old firewalls in there. I went to the director and said, I need some money to replace the firewalls. At that point, we decided, no, it's not the right thing to do. We could have easily just replaced the firewalls with the latest and greatest and have the same architectural setup and be no better off than we are. So we did a security review, and we didn't want to do that in-house, although we wanted to contribute from within house. We had the skill sets, but we need to know what's happening out there. What's the sector doing? What should we be doing? You know, what's the latest and greatest? So we wrote in a number of consultants, and we were very strict on the terms of reference, what we wanted them for. This is not an opportunity for you to sell stuff to us. We want your advice. What's the sector doing? Where are we in that sector? Where should we be heading and how we're going to get there? This third set of consultants we got in actually listened to us and got it right. The other lot of consultants came in and said, well, you need this device for this, and this device for this, and this device for this. So go away. So, I mean, the learning curve for us, make sure you get a good relationship with your consultants. Be very, very clear on what you're asking them to do, and just reiterate it back, what I'm asking you to do. It was a learning curve, and that knocked us back by about 6 months. It really did. And that was once we got the right consultants on board, it was very important they integrated in as part of a team, rather than they're the consultants and this is UCLan. We had to be one team and everything on the table, you know, whether we liked it or we didn't like it. And that seemed to work quite well. As Paul says, we've got the firewalls in place now, and that was a real eye-opener for us. We thought we knew our network. As with yourselves, I'm sure you've got very resilient networks that, you know, when things fail, things carry on working. We put the new firewalls in, and things started to break. And that was a bit worrying, because it wasn't what we expected was going to happen. We expected some teething problems, but things that were working quite happily before stopped. When we did the investigations, we said, well, they should never, ever have worked. I mean, a typical example was the gateway was wrong on one system. It wasn't even the wrong gateway. It was working before. And it was at that point thinking, what's going on here? We put it down to the fact that we believe IPv6 was working and things were actually getting through. So we simplified the network to a certain degree. We have more understanding of that network now, but it also highlighted the fact that we need to standardize. Because if people are putting systems out there thinking they are right and set up right and they're working, and they were, but they're not working right. So the microsegmentation and the work with the NSX will allow us then to say standardise, right, these are the security we need for these devices to talk to these other services, etc. And then we can roll those out, having the confidence that they are right and they've been signed off and checked, and they will modify accordingly.
I think the other thing you've got to bear in mind, it depends very much on your setup, but if you've got an infrastructure team and a networks team at the moment, scrap it, start again, just make one team, because they're going to have to all play nice.
Yeah. We had... we actually had a wall between our teams. The wall was taken down, and it was immediately replaced with filing cabinets.
You can see over them at least now.
It's taken a long time to get there, but the integration, the lines are so blurred that we've got to work together. We can't work in isolation at all. And it took a while to get there. We got old school there, they just didn't want to move, so we got rid. You know, just move on, it's got to work. We find, as with all of the education, is that the students are key. They want to bring their own devices in. They want to do what they can do at home. They want to do it on premise. We're moving more away from the fixed desktops, because students want to be mobile. It's a cost saving for us, because if they want to bring their own device in, we're not paying for those. But we're not like a bank or a financial house where that's your desk. You will access these set of applications, and it will not move, and we can control all those. We can't. Up until 18 months ago, we don't believe we'd actually been hit with ransomware. Then we got our first hit. We've now got to the stage where we're being hit on a weekly basis. We have a ransomware attack. We've got tight controls in how we deal with those. 18 months ago, we'd be down for 24, 48 hours of business will be hit. We've now got it down to 20 minutes where we can identify, resolve that issue. We're not stopping the ransomware, but we're reacting to it, and it's having least impact. Putting the security models in there, etc., we're hoping the fact that the automation will be in there for the ransomware, so it's hitting a single user only, if it does hit a user. So that's our biggest goal at the moment, is ransomware is happening literally on a weekly basis. We're being hit by attacks.
Any more questions? Go on, there must be someone. Fair enough. I think we're done. Thank you very much. I appreciate your time. Thank you.